Hello. So today we are going to spend a little bit of time covering the discussion questions that we've had for both of you who are watching. I want to talk some of the questions we're focusing around statistics. Okay, a number of questions oriented around what are the difference between inferential and descriptive statistics. We cover both of which, actually full lectures on each, but the contrast of these might be pretty important, particularly in that there are other questions oriented around, well, why don't behavior analysts use these? Um, so, descriptive statistics are both common in behavioral science by behavior analysts, as well as common anywhere. So, we might want to know, on average, what's something like. Okay, that's an average. On average, it's this. On average, it's that. So, if you want to know how warm it is in October at Disney World, okay, Orlando, Florida, wonderful place. You might want to know what the temperature is. Okay, but there's 30 days in October. Okay, and what you actually might want to know is you might want to know the average high temperature. So on average, how hot does it get each day? Average is your mean. Okay, when we say average, average and mean mean the same thing. That's that descriptive statistic. It's basically describing a whole pile of data. So you have a whole pile of data. There are 31 days in October. When you take the average of those 31, that is descriptive statistics. Okay? If you ever average anything, okay, so if you ever provide some sort of what we refer to as a measure of central tendency, okay, so the average is a good way to say a measure of central tendency, what most things tend to look like. You also can do the median, which is the middle value. You can do the mode, what happened most often. But anytime you're doing a measure of central tendency, you also need to tell people about how much variability is in there. So if I actually told you, the temperature in Orlando, Florida is highs are on average, 80 degrees during October. Okay? You're not going to go in there assuming that every day is going to be 80 degrees. You know it's going to be plus or minus some amount. So 80 degrees plus or minus this, okay? When you're looking at that plus or minus, how much above, how much below, those are the measures of variability, okay? In your statistics assignment, you calculated variance, which is basically the squared deviance from the mean, okay? And you use that to calculate standard deviation. Standard deviation is very, very common in research as a way to tell you how much variability is in a set. Variance is a step along the way towards calculating standard deviation, okay? Anytime you present any sort of measure of central tendency, you need to give some indication about how much the data spread away from that, okay? So your standard deviation. So mean and standard deviation are a pretty common thing. So on average, it's this with a standard deviation of plus or minus this. Okay, those are descriptive statistics, and those are inescapable. Like if you're going to summarize things, you need to do it in the right way, and those are the best approaches to do it. Inferential statistics are a little bit different. Okay, so you might be interested in if the weather in October is different in Orlando than it is in Kansas. Okay, so for example, in Lawrence, Kansas, is it a different temperature than it is in Orlando? Okay. Now, if you're going to say if you're using statistics to say whether something is different or not, you're making an inference, okay? You're making a statement about the data, not just describing it. You're actually making a statement. So I'm going to say these data are foundationally different than these, okay? So I might look at the average temperature in October in Lawrence, and it turns out it's probably, I'm going to guess, around 60. 60 to 80, that's probably different. If I looked at 60 to 80 and then I looked at how much variability there was around the 60 and 80, now I'm starting to have an idea of whether the temperature is actually different in these two different places. Inferential statistics, all it does is formalizes the process of looking at the different means and the amount of variability around them to say whether there is a difference or not. So a t-test is just telling you is the difference between two groups bigger than the variability within the two groups? So are the differences in the means greater than, in our case that we're talking about, the standard deviation differences, okay? So it's variability within each of the groups. So variability, day-to-day fluctuations in temperature as opposed to temperature differences between the two locations. That's inferential statistics, and it's very, very common for inferential statistics to compare groups who, for example, might have received treatment, might not have. And this is the spot where behavior analysts have often kind of balked a little bit at statistics, because what we do is we develop treatments that are good for the individual, okay? And we evaluate things at the level of the individual. That's what we've talked about during the Goodly portion of the semester, is these single case designs, which evaluate things at the level of the individual. However, group stats are a little bit different, okay? Now I'm looking at, so on average, how is the behavior of individuals who received treatment versus, on average, the behavior of individuals who did not, okay? There are purposes for that. There are good reasons for that. But we don't usually like that. We like to know, did any of the individuals benefit from it? In stats, saying that there's a group difference from one to the other doesn't tell you about any of the individuals who made up those groups. And that's why we tend to not necessarily like these approaches as much, okay? Somebody asked about t-tests. I talked briefly versus ANOVAs. I talked briefly about that a second ago. A t-test is you're just comparing two groups, and you're looking at the variability within the group versus the change in level between the two groups, okay? So variability within each group, change in level between the two groups. And if the change in level, so the difference between my hands, is bigger than the amount that my hands are bouncing up and down here, there's a statistically significant difference. That's what a t-test does. An ANOVA is actually not all that different. So an ANOVA, if it's in its simplest form, is what you do if you had three groups. Okay, so now instead of two groups, I have three groups. So now, instead of looking at the height of adults versus children, I might also include the height of teenagers in there. Okay, to see, and what I'm seeing is, are any of these three groups different than the others? And what we know is, yes, it's probably the case that children are smaller than both teenagers and adults, and there's probably actually, with the variability and everything, not a difference between adults and teenagers. Okay, that's comparing between groups. That's what an ANOVA is for. The nice thing about an ANOVA, and we talked about this a little bit, are these factorial designs. So now we can actually look at the data that differ on two different factors. Okay, so let's say we're looking at, for example, attractiveness out of individuals with blonde versus brown hair that were tall versus short. Okay, and you can actually have, there's four different cells there: a tall blonde, a short blonde, a tall brunette, a short brunette. And it turns out you kind of look at people's subjective ratings of these individuals, and lo and behold, you could end up seeing that there's an interaction such that people tend to like, for example, tall, we'll say blondes, but they don't have a difference between short blondes and brunettes. Okay, those sorts of designs are very, very helpful along those lines. Another question that came up were questions about type 1 and type 2 error. Okay, type 1, and particularly why type 1 error is so dangerous. So type 1 error is saying that there's an effect when there isn't one. So if I'm evaluating a treatment, okay, and I say that the treatment works when it doesn't, okay, that's a type 1 error. Okay, if I say the treatment works when in reality it does not, that's a type 1 error. Whereas a type 2 error would be the treatment doesn't actually work. Excuse me. A type 2 error would be that the treatment works, but I say it doesn't. Okay, it's particularly dangerous when you tell somebody something's going to work and it doesn't. This is how these fad treatments and so on and so forth go about. It's like people say that they work, and it doesn't end up showing that it does. Scientifically, this is particularly dangerous because it's really, really hard to disprove something. Okay, so once something is shown in the literature as having worked, all of a sudden it becomes really, really hard to get it out of the literature showing and say that it doesn't work. So that's one of the biggest problems that we tend to have here. People asked about case studies and a little bit about case studies and archival studies. So case studies, okay? Why somebody would do one of these. Well, the reality is people aren't always intending to do research. So if I'm a clinician and I'm helping folks out in the community, and all of a sudden as I'm doing the study, as I'm working with somebody, I notice that we try something really unusual, we get really great unusual results, but I wasn't set up to do a study in the first place. I wasn't collecting data in the way that we would normally talk about it. I wasn't setting up to be able to have a multiple baseline across anything like that. I just actually had this one subject I was working with, and something cool, really neat happened, and I want to tell people about it. And so I gather all the information that I can about the improvements that I see. So I just kind of like, oh, I had these clinical notes that said this, we saw this at this other setting, people were saying this, so on and so forth. And you just gather all this converging information together and report that. Okay, that's a case study. You're telling people about this case. Okay. That differs from our single subject designs where we've planned out to do the study in the first place. We're collecting data that would allow us to make inferences about so make statements about whether the treatment worked or not in the first place. Case studies are by and large done when something on accident pops up and you just want to make a case to tell people about it. Okay? Archival studies are a little bit different. So archival studies, there's just interesting things in the world. Okay? So I can tell you an example of a study I did years ago. So years ago, I was working in a computer lab as a graduate student. We had individuals taking Psych 100, and every day had, I think we had 15 sections, so every day had 3 different sections that were coming in to take their test, and they were all staggered in terms of when their deadlines were. And I noticed that actually you tended to see people whose tests were due on either that day or the day before. Day before that was due. And you saw this pattern that you didn't see very many people taking their test ahead of time, even though they could. And as the test time came, you tended to see this major spike in the number of people taking that test. I wasn't taking the data for that in the first place, but the computer was automatically recording when people took their tests. That's just the way that it worked. And so I knew that there was found data. There was data laying around there, archival data. And so my buddy Yusuke and I took these data, plotted them out, and lo and behold, they show these beautiful kind of what we talk about in terms of fixed, scalloped sort of patterns. So accelerated patterns within the week, and that kind of basically accelerated all the way up to the deadline, and then they didn't take tests again until towards the end of their test period. That's an archival study. The Masweeney paper that you read, wherein they just kind of went through afterwards and saw, oh, hey, when they started charging people for directory assistance, people started using directory assistance less. Hey, I bet you I could look at the data and see if it actually worked. Okay, and the company's keeping the records, so I can go back and ask the company to give me these data, and I can test to see if it worked. Those are archival studies, and they can be very useful. You didn't manipulate it yourself, so you can't say anything causal about it, but it can be useful. Okay, and that's really, really, really helpful. One last question I see here is asking about chi-square versus a t-test. So chi-square is essentially when you have basically yes-no data, okay, binary data, so yes, no. And you're basically, as opposed to a t-test is when you have kind of 1, 2, 3, 4, 5, no, kind of numerical sort of data rather than just kind of yes-no sort of categorical sort of data. Chi-square is basically the distribution of, in these 2 categories, what we expect it to be. So if there's 2 categories there, you'd expect to see 50-50. And you basically test out the distribution to see if you say the same thing. Okay? These are the major questions that I saw. I hope everybody has a success taking their test, and I hope everybody has a marvelous weekend. Thank you.